In the last class, this is the Professor Resuri. Good morning to all of third year EC students. This is Industrial Electronics, Unit 4, the third lecture we are discussing. So, as in, what is induction heating? Induction heating is a heating procedure where the metal rod or conductor is placed in a coil where high frequency current is passed through the coil, which produces magnetic flux, and an EMF is induced in it. This induced EMF produces a current through the path. The current is known as eddy current. Eddy current is used for heating, of course, these metal rods or metal pieces. This is called induction heating. Of course, frequency of this high frequency current source is 500 Hz to 500 kilohertz. The heat generated is due to eddy current loss. Okay, so that is what is induction heating. This induction heating is very much used in industry for surface hardening of metal rods, okay, conductors, and sometimes metal sheets also. Okay, so we have seen at high frequency the current is concentrated only on the outer skin of the conductor, because as the frequency increases, the depth of penetration of the current decreases. Okay, finally, if you go above 500 or 550 kilohertz, the current will not flow through the conductor at all. It just touches the conductor and goes into free space. That is what we call wireless. Okay, because it will not flow through the wire. Current will not flow through the wire. It goes wireless. Okay, that's how we get above 500 or 550 kilohertz. It becomes wireless. So that's why induction heating frequency is used from up to 500 kilohertz only. So otherwise it becomes wireless then. Okay, so the high frequency current is concentrated only outer skin of the conductor. This is known as, of course, skin effect. Skin effect is, of course, extremely useful in induction heating. Skin depth is given by delta is equal to square root of 1 by 2 pi. Delta is equal to 1 by 2 pi square root of mu r sigma f into 10 to the power minus 9 centimeters, where mu r is relative permeability, henries per centimeter, sigma is conductivity, moles per centimeter, and F is the frequency of heating current source. Okay, so the depth of heating or skin depth, the depth where current goes into conductor depends inversely proportional to square root of mu r, that is the relative permeability of the material, then sigma, conductivity of the material, and F is the frequency of the current source, frequency of heating current source. Okay, so we can calculate how much depth you require heating based on using this equation, skin depth. Okay, so once we calculate this depth, skin depth, we can find out what is the total power entering into metal per square centimeter of the surface is given by equation. Finally, it is total power is 4h square by sigma delta, where h naught square. H naught is magnetic field, and sigma is conductivity, delta is skin depth. Okay, so it is directly proportional to square of magnetic field intensity, inversely proportional to conductivity and skin depth, inversely proportional to skin depth. So if you substitute equation for delta skin depth, then we can get the another equation, equation 2, power total is equal to 8 pi h naught square by square root of sigma into square root of mu r f into 10 to the power minus 9. This is of course total power is proportional to again h naught square, total power is proportional to square root of f, total power is proportional to square root of 1 by root sigma. Okay. So using these equations, we can find out what is the total power that is entering into the metal rod or metal piece or conductor. So based on that, we can calculate the current flowing, the depth of current, and also heat produced into metal rod on the surface, that we can find out very easily. Okay. So based on these equations, we can accurately predict the heat produced in the rod. Okay. Then we have some characteristics features of induction heating. Here, very high heating rates can be obtained. Very high heating rates can be obtained. Number 2, the method is suitable for automatic control of temperature. So number 3, the portion of surface to be heated can be accurately controlled. Number 4, working conditions are pleasant near induction heaters. Number 5, that's why induction heaters can be operated by unskilled labor in industry. Of course, the cost of heating furnace and equipment is somewhat high, so overall efficiency is 50% in most cases. So in some cases, large scale, it may not be economical. You want to heat thousands of rods in the industry, then this induction heating procedure may not be economical. Of course, the main advantage is the heat is concentrated near the surface of metal piece. Hence, induction heating becomes very useful in surface hardening of steel, rods, etc. Number 7, it is possible to have rigid control over the surface areas to be heated. This reduces wastage of heat. Number 8, number 9, with the timers it is possible to control very closely total heat transfer to the workpiece. Okay, these are some of the characteristic features of induction heating in the industry. So here there is a high frequency power source for induction heating. Okay, practical circuit which is used in industry. The AC power supply, there is a converter, and of course there is an inductor L and SCR in parallel, and there are 4 SCRs in bridge, and in the middle again inductor L dash, inducting coil L dash, and the induction heating coil to be placed there. There is a provision for placing induction heating coil, and in parallel there is a capacitor. Okay, there is typical induction heating circuit using voltage fed inverter. In induction heating equipment, if conductor is surrounded by AC heater coil, it will behave as a transformer and current will circulate in the conductor. The amount of heat will be a function of flux coupled, the metal characteristics and frequency. So the amount of how much heat produced depends on magnetic flux coupled and depends on the metal characteristics like conductivity, and also it depends on frequency of the source. Okay. A typical induction heating circuit is shown in the figure. The circuit employs voltage fed inverter. Normally, Furnace coil tends to operate like a short-circuited transformer and hence work at lower value of PF. The load coil L- is compensated for PF with a capacitor. The DC series inductor and DC parallel capacitor keeps the voltage constant. The load current IL now passes through the thyristor inverter, formed by 4 thyristors in bridge configuration. The load voltage is a function of operating frequency compared to series resonant frequency F0. The F0 is given by 1 by 2 pi square root of L dash C, where C is the capacitor shown in the heater coil and L dash is of course heater coil. Next, main applications of induction heating. There are 4 applications. Number 1, surface hardening of steel. Number 2, annealing of metals like brass, bronze, etc. Number 3, soldering at high temperatures or brazing. This is called induction heating soldering. Number 4, other applications. First one is surface hardening of steel. Materials which employ the process are crankshaft, bearings and cans, gear, teeth, cylinder, surgical and medical instruments, special knives, etc. These are all using surface hardening. Steel parts that undergo fractional wear and tear employ the process. The steel rod is properly placed in the AC magnetic flux produced by work coil. You can see the diagram. Surface hardening of steel bar by high frequency work coil. The steel rod within high frequency coil. That is what is induction heating. The steel rod is properly placed in the AC field flux, that is magnetic flux produced by work coil. At 350 kHz frequency, skin depth for steel above Curie temperature is about 0.1 centimeter, that is 1 millimeter. So if you are employing 350 kHz frequency and steel rod conductivity, if you calculate, we can find out what is the skin depth. Skin depth, it is about 1 millimeter. The power density is sufficiently high for producing the power density is sufficiently high for producing a sufficient temperature gradient to limit hardening to desired depth. The power density is sufficiently high for producing a sufficient temperature generated a temperature gradient to limit hardening to desired depth. After the surface temperature is of correct value, steel rod is immediately quenched in water or oil. The induction heating takes place for about 8 to 10 seconds to reach correct temperature. This is what we call surface hardening. I'll repeat again. Materials which employ this process are crankshaft bearings, cans, gear teeth, cylinders, surgical and medical instruments, special knives, etc. Steel parts that undergo fractional wear and tear employ the process. This process. The steel rod, as shown in the figure, That is, figure is surface hardening of steel bar by high frequency work coil. The steel rod is properly placed in the AC field flux, that is magnetic flux produced by work coil. Of course, at 350 kHz frequency, skin depth for steel above Curie temperature is about 0.1 centimeter, that is 1 millimeter. Okay, so the heat will go up to 1 millimeter. That is what is skin depth. The power density is sufficiently high for producing a sufficient temperature gradient to limit hardening to desired depth. Okay, after the surface temperature is of correct value, steel rod is immediately quenched in water or oil. The induction heating takes place for about 8 to 10 seconds to reach correct temperature. Okay. Number 2 application, annealing of metals like brass, bronze, etc. Materials like brass, bronze, etc. when cold, worked by process like drawing, punching, rolling, spinning, etc. They get hard and brittle. Any further work after on the material meets the breakage. Okay? So here materials like brass, bronze, which are brittle, etc. when cold, worked by process like drawing, punching, rolling, spinning, etc., they get hard and brittle. Any further work after this on these materials meets with breakage. So because they are more brittle and hard, they meet breakage. Okay? They need what you call annealing. If annealing is done by induction heating method, a temperature of about 750 degrees centigrade may be reached for a bar half-inch in radius in approximately 1 minute. Okay? But of course, you want to reach this temperature, normal old furnace method will require 1.5 hours. And also, we get what you call a scale formation. Okay? So that can be avoided here. We can reach 750 degrees centigrade within 1 minute. Within 1 minute. That is what you call annealing. Annealing can be done very economically, very fastly. So large number of rods or vessels can be annealed using induction heating method. It is very fast and also very efficient, okay, compared to old furnace method. Then what you call soldering at high temperatures or brazing. Soldering for joining two pieces of steel, iron or similar materials. High temperature soldering or brazing can be used. With suitable soldering materials like alloy of silver, copper, etc. The joints to be heated, placed side by side with the soldering materials, and heating takes place in the presence of suitable flux. Okay. So this is what you call high temperature soldering at high temperature. Okay. For steel, iron, or similar materials, high temperature soldering, and also brazing. Okay. Other applications. Induction heaters can also be used for welding, sintering, powder materials, and drying materials, sterilizing surgical instruments, etc. Induction heaters can also be used for welding purpose, for sintering powder materials, drying paint on materials, sterilizing surgical instruments, etc. Because it produces heat, so it also sterilizes surgical equipment. Okay. So that's how we have, of course, number of applications of induction heating. Okay. Mainly, it is used for surface hardening of steel rods in industry, and of course annealing of materials like brass, bronze, etc. And also, of course, high frequency, high temperature soldering, high frequency and high temperature soldering and brazing purpose in industry. So it is a very important heating technology, heating method, which can be employed in industry. So, of course, now we have latest equipment which can do this induction heating. Induction heating, one of the thing is it is also very fast, very fast. Okay, within 1 minute we can get to reach a temperature of 750 degrees centigrade. So you can imagine how fast it is and how much heat is produced in a short time. So that's why we can harden number of steel rods in a short period. So it is, we can make it automatic also, because the timer is fixed, and when desired temperature is reached, automatically the timer is switched off, and next rod goes into coils, and that's how it works. There is a method, of course, for cooling the heat also. There is provision for cooling this thing. Again, heat will be produced within seconds and within 1 minute, and so we can at least process, harden surface of the steel rods within 1 minute. Every 1 minute, one rod can be hardened, so it is very fast. We can process large number of such steel rods using this surface hardening for surface hardening purpose. So that's why this method, induction heating, is very fast. So normally it takes only 10 seconds only. Even if you want to higher temperature, maximum it goes to 1 minute only. Okay, not more than that. Okay, so most of the steel rods will be taking only 10 seconds. Similar for annealing purpose also, maximum it takes only 1 minute. Whereas in the conventional method, it goes 1.5 hours or 2 hours. Okay, in hours. Whereas it is in 1 minute, less than 1 minute, in seconds. This operates in seconds. Okay, that's why particularly for soldering and brazing metal, steel, iron, and similar metal rods or sheets, pieces. This is called high temperature soldering and also high frequency. and brazing also, for brazing purpose, that is particularly for smoothening some of the surfaces. This induction heating methodology is used. Okay, this is also very fast. We can do soldering and brazing also within seconds and minutes. So induction heating, of course, is used even in welding also, welding for joining two metal pieces, because we get very high temperature, very fast welding. Okay, and also for drying paint, it is normally induction heating methodology is used. Paint, once the paint is done, it will be hot, it will be dried using induction heating. Okay, and also for sterilizing, want to sterilize any equipment, particularly sterilizing surgical and medical instruments. This induction heating procedure is used, because there we have to sterilize only surface, particularly knives and scissors and some other surgical equipment instruments can be heated on the surface. They are put in a coil and only surface heating is done, so that they are sterilized very fast. Within 1 minute, they are still, we get required temperature, and all the germs and virus, bacteria, they are killed. Okay, the sterilization is very fast compared to conventional sterilization. This induction heating sterilization is uh, more appropriate, and also more foolproof. Okay, so no bacteria will be there on the surgical instrument, particularly knives, scissors, and some other surgical instruments they are using uh, in the operation theater and otherwise also. uh, all the medical equipment can be sterilized using induction heating. So induction heating we can consider as a very fast and very fast FAST, very fast and very effective method of heating. So in industry, and also you can do it, induction heating can be done on large scale. Okay, not for one or two pieces. So hundreds or thousands of pieces it can be done. Okay, that's how induction heating is used in industry. Okay, I think all of you have understood what is induction heating, what are its characteristics, how induction heating is produced in a magnetic coil, and also what are its characteristics, and particularly what are its applications. That is the main part. Already I have given my personal notes uh, to the HOD madam. I think all students will get the scanning of my notes on Unit 4. So all of you, please follow that notes. It is very clearly visible. Okay, using cam scanner, I have scanned all the pages of my notes. Okay, thank you very much, and we will meet again for the next class.